All right, the next key criteria that we talked about is the accuracy, which in the oil and gas industry, we're quite good at measuring what it is that we produce, as that is what we get paid on, as well as all of the things around operations, at least in the engineering side. And so when we look at the accuracy of the emission quantification within the protocol, there's really three key criteria in the life cycle of the hydrocarbons that produce emissions. There's the downstream operation, which is really the end use of the produced products. There's the refining of the produced products. And then there's the upstream emissions, which is operational emissions, as well as fugitive methane emissions that come from various operations. We know that in the oil and gas or energy transition and kind of environmental industry, there's three scopes that are considered. Scope 1, which is directly from the operations. So that would constitute fugitive methane emissions, flaring, venting, on-site combustion, operating, producing facilities, et cetera. In this initial version of our protocol, we are focusing purely on the emissions that come from either the volumes themselves or the quality of the produced fluids. This is because there's a lot of variability in operational emissions, and this is something that will be implemented in the future as the industry standardizes on ways and systems to measure these emissions. Scope 2 is purchased energy and materials required for the production. And scope 3, as I mentioned, is the end use of the products themselves. So combustion of the gas, the oil, the NGLs, et cetera. Fugitive methane during transportation, and so on. And so the way we've really focused on measuring these, first we have the third-party reserve report, which, as we mentioned earlier, it's the proved developed reserves that are under consideration because those meet the high requirements for additionality. And then there's also the quality of those products being generated, which ultimately reflect the emission intensity of those. And we received those from a gas analysis report, which has information about the gas heating value, as well as the composition of any associated and natural gas liquids, and oil sales receipts or other fluid quality reports. These then feed into these 5 scopes that I mentioned earlier. We've got the intrinsic oil phase emissions, which is tied to the API gravity. And this is derived from the end products of the oil. So if there's heavier oil results in heavier products, more emission intensity. Lighter oils result in lighter components with slightly less emission intensive products. Part of that thing tied to the API and quality of the oil is also how much energy it takes to refine the product into its individual component end use products. And that is also correlated through literature, and this relationship is used in our determination. Then there is the natural gas, the methane, which using the heating value of the oil, of the gas, we kind of take into account the heavier components that may be present in it, and thus resulting in slightly higher emissions, and that is factored in. Then there's the fugitive methane component, which is just methane leaking from facilities during flaring or other operational activities. For this, we use the 100-year global warming potential for methane to be a little bit on the conservative side as well. And finally, there's the natural gas liquids, which, as mentioned earlier, is derived from the gas analysis report, and simply a molecular weighted average of the individual components and their emission intensity is considered in the calculation.